Okay, hi. I'm going to hop straight into it, as I think I'm a little tight on time. So, in an age of increasing digitalization, why do we care about making PDF documents? For one point, there's accessibility of paper will always be good. Legacy requirements, lots of systems, especially in the public system in Norway, require that you archive the result of decisions that have happened in a system that will preserve the data in a way it can be read over time. PDFs work really well for this. Also, digital signature solutions require documents that can be reproduced in much the same way and a lot of the same requirements. So we've used PDFs as input to digital signature processes. So that's we still need these PDF documents, even though a lot of the systems we have are becoming more interactive. In the good old days, I'm a Java guy mostly. We had these specially designed tools to do this. This ends up with a lot of duplication of effort if you want to have components looking similar in your printed documents than you had in your rich web interfaces. And I've been on a couple of projects where people have tried to mitigate this by creating PDF documents from their front-end applications. The first of these was a React application with a Java backend. And when the React application said, okay, now it's time to create a PDF, then the Java application would shell out to a headless browser. This was a few years ago. This was quite an ancient, unmaintained headless browser that then made a call back into the front-end application, rendering a special route to create the layout that we wanted for the letter. But this architecture had multiple problems, but the most important one was it was really challenging to get authentication to work here because there was no way to hand over authentication from the front end to the separate browser process. The other system where I've worked with similar things more recently, it was an Angular application, again with a Java backend. And this application was a case handling system for the counties in Norway. And in the front end, they had a rendering of the letter that they were going to send out that was editable in the case handling system. So everything was already laid out in the front end there. And then what they did here was they took the inner HTML of the rendered Angular component, threw it at the backend API, that then used a microservice that again shelled out to a browser to render the PDF. This doesn't have the same security problems as the previous solution, but here we have validation problems. There is no way for this backend API to trust the HTML that it's been sent to know that the content of the document is really what we intend it to be. If your front-end application has a cross-site scripting attack or a script injection or something else, then we've got big problems here. So after seeing this pattern of people attempting to use their single-page application frameworks for generating PDF documents, I decided to sit down and see if I could make it even a bit better. And one core part of this solution is Angular Universal. Just in case of the very simple version, if there's anyone who's still not aware of what Universal is, it's the Angular's server-side rendering component or application plugin, whatever you want to call it, so that instead of just serving a minimum HTML document with the JavaScript and then loading all the data in the front end, for the first load, what Universal does is on the back end, it will process all of your JavaScript, do all of the HTTP calls to populate your components, and return the finished HTML to the browser so that the first render will have all of the content in it, and then things get enriched. When using this kind of thing for generating a PDF document, we only really care about the first render. So this works really well, in my opinion, for my admittedly limited proof of concept. But I set out for doing some concrete code around this, not just thinking it out in my head. So the goals were to use the existing front-end framework, in this case Angular, for creating a PDF layout. I wanted to use an up-to-date rendering engine. Both of the previous solutions I've seen in use were using quite old browsers that no one dared to touch and update because they weren't sure how the rendering was going to break. I want to make sure that the markup used when generating the PDF is from a trusted source, one that I control, and I know that the content is as expected, and that not making any compromises on the security and access control of the APIs. So the way this looks for my proof of concept is I've still got an Angular front end. I've created a mono repo, so I've stuck to Node on the back end. So there's a small Node Express server here, just to tie things together. I've created a very similar to the last solution I talked about. I've created a front-end component, an Angular component that is data-driven for rendering the letter that can be used on the front end. So when using it in the case handling application, you can still use it very reactively. You can edit the data and edit everything in line and see the changes in real time. But then when you want to generate something or pass everything necessary to the backend, you only send the data that is then validatable. You don't just send a clump of HTML that could be anything. You send data that you know is strings, numbers, and data types that you can trust and do some more sanitization on if necessary. And then what I've done is I've created a separate Angular universal application that uses the same letter component as we use in the front end. As it's data-driven, we don't need to make any changes because of the way we're getting the data from different sources, but we can just push the data in. So then the API that's coordinating the process can make the GET request to the universal application. The universal application will then go and get the data that it needs for rendering the letter component, again from the API. And then I've created another Node version of my little microservice, but based on Puppeteer, which makes updating the web browser to the latest headless Chrome trivial. It's simple to stay up to date. And the server-side rendering here should work pretty much the same as it works in your desktop browser. This is how it looks. I'm no graphic designer. Sorry. But so here is my example case handling application. You can see the rendering of the letter in line. You can see that there's some UI around that could interact with this. If this was live, you could interact with the components on the left and see that things change in the letter. This is how things look in the Angular Universal application. Here there's of course no Chrome. There's nothing around it. We just output the component once we've retrieved the data. And here's how it looks as a PDF in the standard evince PDF reader on Linux. So everything looks the same, pretty much. Some flow differences, but nothing we're not used to handling. So a quick look at the code that sews this all together. Well, one thing I wanted to mention first, the HTML that comes out of the Angular Universal application Any styles you've defined on the component level, if you've got a component and defined a CSS file at the side, or in your directive written CSS inline, that will get inlined in the HTML that is sent to the browser. If you have a global CSS file, then that will be linked in as normal with a relative path. And there is the base href is defined in the markup. This is one of the first challenges, because the way my HTML to PDF service that calls Puppeteer works is it takes the markup it's sent in a post body, saves it to a temporary file on the file system, and then fires up Chrome headless, loading the local file. So in this case, it won't find the CSS file according on the local file system, because it's not been provided. Multiple ways I could have solved that, but I did it this way. So in my Node Express API backend, to tie everything together, I just exposed a simple get for getting the PDF, pass the parameter, and then I do a get to the universal application, reading in the text that came in the response. I then do a really dirty hack to switch out the href, the base href. Not very happy with that, but it works and it's fairly stable. Then we post the result of the previous call into the HTML to PDF service, and then we take the result from that and send it back to whoever created the document. Like in the diagrams here, I've drawn the arrows that it's the browser initiating this interaction. But in the case of some kind of automatic case handling, or some automatic handling of something else that needs to go into an archive journaled away somewhere, this could be initiated completely in the background by something else. But that's the final, that's all it takes to couple the parts together. Back to the slides a second. So we've got this, all of the parts talk together, but I've not got in, this is before I've tried to add authentication. I'm a fan of using JSON Web Tokens and holding those in the front end. So normally I'd call my backend APIs, there'd be an interceptor in the front end, a HTTP interceptor, that would then make sure the token is added to all the API calls. Passing this token through the Node backend isn't particularly trivial. No, it isn't particularly difficult. The more difficult part is getting the token through the Angular universal application. This was something I scratched my head about for a little bit. But the solution is very similar to the front end, where again we use a HTTP interceptor. And it looks something like this. The cool thing here, when you're in a universal context, then you have the opportunity to inject the request object that comes in from the Express runtime, which then means that it's as simple as propagating through the Express application. I can just read the header from the original HTTP request that caused this page to render. And then I can add it to the headers that are sent to the outgoing HTTP call. Configuring this up is as simple as any other interceptor. Here I made sure to put it on the app server module, which is where you put the things that are unique to the universal runtime. And that just worked. Very happy, a simple solution in the end. So then now we've got all of this working, And we have, good time. And we have authentication maintained. But this loop between we have this loop of communication between the HTTP API and the universal application, which seems a little silly because the HTTP API is sitting on the data from the start. So is there a way? My next thought process was, is there a way we could get rid of this circular loop, both to avoid some network calls, it minimizes risk of anything failing, and could simplify the authentication that we just went through. So while we have that option, if we don't have the data up front, if there's other services we need to orchestrate, if we do have the data up front, what we can do is we can refactor this so that the API doing the orchestration now can post the data to the universal application instead of doing a get. How do we do that? Well, there's a few different steps. The first is in the server TS file of the universal application. The line that's highlighted now, that's what you get by default when you do ng add universal. So I just duplicated that with post instead of get. And it seems to initiate the requests, and the rest of the universal runtime doesn't seem to care. It works fine. Then I needed to change my route because we're no longer doing a lookup of data. We no longer need that ID on the way in, so we can remove the ID from the route, however you want to pronounce it. And in my component that then wraps the common letter layout component that gets the data, this can now be refactored from using the ID in the route and doing a HTTP lookup. It can be refactored to here. We can do similar to what we did in the HTTP interceptor and inject the original express request. And then we can just pull the body out of that and use that directly. No need for any observables here because that data is not going to change. The data that came in on the post request is static. That's never going to change. So it simplifies a little bit of code here too. Removes an async pipe from the template. And then in the API, doing the orchestration, then we obviously need to look up the data first. I had a hard-coded list in my proof of concept application. Then we need to change the request from a get to a post and just stringify that object into the body, and it works. And that was a copy of the previous slide for no reason whatsoever. And there we have it. I managed 19 minutes. The code in its current state is available at this URL here. Yeah, we've achieved all of the goals. We're generating the PDF from an up-to-date browser because it's been installed through Puppeteer, which has all the mechanisms to do that. We're reusing the existing front-end Angular layout competence on the team because we're using exactly the same components on the front end and the PDF rendering. The markup is coming from a trusted source because the API is orchestrating against another API that it trusts instead of trusting something from a random web browser out anywhere. And security is maintained because there's no hop between browser processes that would need to do any data lookup. So we've actually managed to improve on both of the solutions that were originally in. While I mentioned the codes here, it's not up to the 7D standard as presented yesterday. I'm going to fix the README file by the end of the day today. It needs a little hand-holding. But other than that, yeah, it's all there. Go ahead, play, ask questions.